Hello everyone, welcome to SciMath. So today we are going to solve for the 2012 United States Physics Team F equals MA contest. So this is the first round of the United States Physics Olympiad 2012. So let's begin. So we have 25 questions and we have 75 minutes to solve. And here maybe a little longer since we can explain all the things. And we use G equal to 10 newtons per kilogram throughout this test. And these are the instructions. I'll open this test until to begin. Well, we just print it out. So let's begin. So let's look at the first question. So consider a dripping fault where the faucet is 10 centimeters above the sink. The time between the drops such that when the first drop hits the sink, one is in the air and another is about to drop. At what height above the sink will the drop in the air be right as the drop hits the sink? That's an interesting question. First we have a faucet, and we have a drop going down. One is already hitting, one is about to drop, and one is in the air. So we assume that say this height is equal to h, and the time it takes to drop to the ground is equal to t. So what is t equal to? Well, we know acceleration formula, kinematic formula. H is equal to 1/2 gt squared. So what is t? T is equal to 2h divided by g, and all of them square root. Alright. So if take for t seconds to drop from here to here, and by the time it dropped to the ground, hit the ground, one is about to drop and one is in the air. So we know that the period of the drop getting restored must be smaller than this t, and have this be smaller than 1/2. Why is 1/2? Because when it dropped to the ground, one is in the air. Yeah, it's already dropping. One is about to drop. So the frequency have to be, the period have to be smaller than 1/2 of the t. So with t is equal to 1/2. T about 1/2 of the t. So now let's calculate the distance it traveled. Again, if after t, another drop is about to drop. So let's calculate again. H is equal to, this h is different than this h because we want to calculate this height. The drop from the ceiling to the drop that's in the air. So h is equal to 1/2 gt squared. H is equal to 1/2 g times t is 1/2 of the t, of the big T. This would be a big T. So 1/4 times t squared. So it's 1/8 times g times t squared. Okay, so now we can plug in this formula to solve for h, and then 10 centimeters minus h will be the answer. So let's calculate using our calculator. Okay, I have a calculator, just trust me, I'm using it. So h is equal to 10 centimeters, so it's 0.1 meters times 2 divided by g is 10, and all of them square root will be equal to the period, the time it dropped to the ground, and then divided by 2 will be the period, and this period square times 10 divided by 2 will be 0.025 meters times 100 is 2.5 centimeters. So 10 centimeters minus 2.5 centimeters is 7.5 centimeters. 7.5 is between 6 and 8. So the answer is B. Okay. So the next question. A cannonball is launched with an initial velocity of magnitude v0 over a horizontal surface. At what minimum angle, zeta, above the horizontal, should the cannonball be launched so that it rises at height h, which is larger than horizontal range r, and when it returns to the ground. So we draw the picture here. How are we going to solve this? So let's recall our projectile motion formula. What is the maximum height of the object? Height. So the time it takes to reach the height, because at the height, the vertical velocity is equal to 0. So we know the t, the time it takes to reach the height, has to be equal to velocity divided by gravity, because gravity times t just reached the velocity, cancel out with the velocity. So with the speed should be same, because we don't want to consider magnitude. Then what is the kinematic formula for the height with some initial velocity? We know it's v initial, because here is a sign, we only consider vertical part, remember. Sine theta times t minus 1/2 g times t squared is equal to the maximum height. So what is the maximum range? Maximum range is 2t, because it takes t to get you here, so which is half of the range, because it's a parabola. We using the symmetry principle, we use half the time to get here and half the time to get here, so full period should be 2t. So v naught times cosine theta, because now we consider horizontal part, times 2t. That will be equal to r. So we want h, which is larger than the horizontal distance, bigger than r. So let's plug in t to each equation. So v naught sine theta times v naught sine, this v should be v naught sine, because we only consider vertical part here. V naught sine, we should write it here. V naught sine times v naught sine divided by g minus 1/2g times v naught squared sine square naught divided by g squared. So these two cancel out, and this should be just square. Don't need to worry about it. And the final result will be v naught squared times sine squared theta divided by 2g. That's h. What about r? R, let's plug in again. This one have to be bigger than 2 times v naught times cosine theta times v naught, so we square this, times sine theta divided by g. So now we can cancel out some terms. Times both sides by g, eliminate g, v naught, eliminate sine, 1 of the sine, and multiply both sides by 2 times 4, divide both sides by cosine, divide by both sides by cosine. So we have tangent of theta have to be bigger than 4. Okay, now we can find the limiting condition. What is tangent? Arctangent of 4. Let's plug in our calculator. The arctangent of 4 is equal to 75.96. So it's about 76. Okay, 76 here. Minimum have to be 76. Bigger or equal to 76. Okay, next question. An equilateral triangle is sitting on the inclined plane. Friction is too high for it to slide under any circumstances. If the plane is sloped enough that can tipple down the hill, what angle of incline is necessary for it to start to topping? So it's a very easy problem. We have an equilateral triangle sitting here. So in order for this is the angle for it to tip, the center of mass of this equilateral triangle have to be over the points of contact. So we know this is an equilateral triangle and it's pretty symmetrical. Then this angle have to be 60 degrees in order for the center of mass of this equilateral triangle to be just on the tipping point. So it's 60 degrees. Look, the next question. A particle at rest explodes into three particles of equal mass in the absence of external force. Two particles emerge at a right angle to each other with equal speed v, with the speed of the third particle. So first we have three particles in a split explosion. One move to here, one move to here, one move to here. Two of them are right angle, and those two are v. So according to the conservation of momentum, and these have the same mass, mv, and v prime. So according to the conservation of momentum, mv plus mv plus mv prime have to equal to 0. These are the vectors. So now we can consider these two up because they are. Let's consider these two forces combined into a single force. Let's add the vector together. We have this force. And according to conservation of momentum, this vector have to be exactly the opposite direction, equal in magnitude with this momentum. And because they all have the same mass, masses cancel out. We don't need to worry about it. So we know. So we just add these two vectors together. So what is this vector? What is this vector? It's just a right angle, and it's an equilateral triangle. So v squared plus v squared over and square root, and I'm going to Pythagoras theorems. So we have 2v squared square root. So it's square root of 2 times v. So it's b. So 5. Problem number 5. A 12 kg block moving east at 4 meters per second collides head-on with a 6 kg block that's moving west at 2 meters per second. The two blocks move together after a collision. What is the loss of kinetic energy in the collision? Oh, so this is a problem about collision and energy loss. So we have a line and two blocks moving toward each other. One moving here, one moving here. One is 12 kg, one is 6 kg. One is 4 centimeters per second, one is 2 meters per second, 4 meters per second. Then when they collide, they move together, so they stick together after collision. So it's a perfectly inelastic collision. So let's calculate. So 12 kg times 4 meters per second. Let's consider here is positive direction. Going to minus 6 kg times 2 meters per second have to equal to the final velocity times the mass total. So it's 18 kg. So what is v? V is equal to, let's just use we don't need to use calculator. So this is equal to 48, this is equal to 12. 48 minus 12 is 36. 36 divided by 18 is equal to 2. So v is equal to 2 meters per second to the right. So what is the kinetic energy of the system? So 1/2 mv squared do 1/2 times 18 times 2 squared is 4. So we have 36 joules. And what is the kinetic energy before the collision? Before the collision, let's do again 1/2 m1 v squared plus 1/2 m2 v squared, v1 squared, v2 squared, actually we said. So we have 1/2 times 12 times 4 squared is 16 plus 1/2 times 6 times 2 squared is 4. So we have 6 times 16 plus 2 times 6. So we have 96 plus 12, which is equal to 108. Right, 108. So 108 minus 36 equal to 72. So the answer is 72 joules here. Okay, let's see the next question. Oh, I missed the calculation here. The next question. Question number 6. So here we need to see the following information first. So the two canals are arranged vertically with lower canal pointing upwards towards the upper canal and the upper canal pointing downward towards lower canal. 200 meters above the lower canal, simultaneously they both find muzzle velocity, which is the velocity they initially have, the launching velocity. The lower canal is 25 meters per second, and the muzzle velocity of the upper cannon is 55 meters per second. So how long after the cannon fire do the two projectiles collide? So let's see. Here we have h distance. One is launching downward, one is launching upward. So let's write out the equation of motion of both cannon. So the upper cannon is 55, is v up times t plus 1/2 gt squared. G is doing positive work for the upper cannon. And what about v down? V down t should be minus 1/2 gt squared. And because this one's launching upwards, so gravity is doing some downward push on that, a downward pull on that cannon. And we add them together, we should get h, right? Because two trajectory, before they collide, t is the time it takes for them to collide. So to add them together should be equal to h. Is that right? 200 meters. And we can see that these two terms cancel out. So we just get VU plus VD times T is equal to H. So what is T? T is equal to H divided by VU plus VD, which we both know them, right? So we know that H is equal to 200 meters. 200 meters divided by 25 plus 55, because here the equation 25 meters, the lower canal, the upper canal is 55 meters, which is equal to 200 divided by 80. Cancel out the terms, and multiply by 2, divide by 2 again, so we have 2.5 meters. Okay, so the number 7. For how far beneath the top cannon do the two projectiles collide? Okay, so we now know the time already. Let's calculate the first equation, this equation, in order to find out the distance, because this is the distance the top cannon traveled. This is distance the top cannon traveled. So H is equal to V upper times T plus 1/2 gt squared. So we know T is equal to 2.5, so H is equal to the top cannon have 55 meters per second of speed. Remember that. So 55 meters per second times T is equal to 2.5 plus 1/2 times 10 times 2.5 square. So H is equal to let's use our calculator. 55 times 2.5 plus 0.5 times 10 times 2.5 square, which is equal to 168.75, which is about 170. Okay, so 170, that will be the solution. So now let's look at number 8. So block of mass m equal to 30 kg is moving on a horizontal surface towards a massless springs with spring constant k equal to 80 meters per second. The coefficient of kinetic friction between the block and the surface is mu k equal to 0.5. The block has speed of 2.5 meters per second when it first comes in contact with the spring. How far will the spring be compressed? How far will the spring be compressed? Okay, so first we know there are two things we need to consider, which is the spring potential energy and the energy absorbed by the friction. So let's see, draw a picture. This is the wall, this is a spring. It's a very bad drawing spring. Then we have a block here. The block is moving with the speed toward the spring, right? Well, speed when it first contact the spring, toward the spring. 2.0 meters per second. And coefficient of friction is 0.5. Spring constant is 80. So by the energy conservation principle, we know the kinetic energy, initial kinetic energy of this block had to be completely transferred when how far was spring compressed. So it's completely compressed, and which means the block stopped. All the kinetic energy transferred into spring potential energy, and the friction, the work done by friction. So now we are going to solve for x. Just solve for x, nothing big deal. So 1/2 mv squared, which is that? M is equal to 3 kg. We've got to write that down. 1/2 times 3 times 2 squared is 4, which is equal to 1/2 times 80 times x squared plus friction mg mu. That will be the friction. So friction mg mu, which is 3 times 10 times 0.5, which is 3 times 5, which is 15, plus 15x. So I write it down again. Here, write it down again. We have 6. Right hand side is 6. It's equal to 1/2 times 80 is 40 times x squared plus 15x. Now we move 6 to the left, so 0 equal to 40x squared plus 15x minus 6. And then we use our quadratic formula. Negative 15 plus and minus the square of 15. What is the square of 15? 225. Minus the minus 6 times 4 times 40, which is plus 4 times 6 is 24 times 40 divided by 80. So let's calculate that. We cannot do the minus here because we cannot have a negative compressed spring, right? It goes here, but the spring compresses to that direction. So we can ignore the negative sign. We just have the plus sign. So let's try. And this should be bigger than 15. So negative 15 plus the square root of 225 plus 24 times 40. And then all of them divide by 80. So what is equal to? 0.243. So we have 0.243. It's about B. B is the correct answer. Now let's look at the next one. Problem number 9. So a uniform spherical planet has radius r and acceleration due to gravity at its surface is g. What is the escape velocity of particle from the planet's surface? So here we need to use a little bit of calculus. F equals ma do require some limiting understanding of calculus, elementary understanding of calculus. Don't have to, but here I'm going to use the method because I don't know other methods. So here, in order to calculate escape velocity of an object from the planet, we need to take the integral from r to infinity of the gravitational force on the object with distance dr. So we have a planet with radius r, and we want to fire some object, throw some object very, very hard with velocity vc, escape. Then it will escape through infinity, running away from the gravity of the planet. If you just throw a stone, it will just fly off and come back to the ground. But escape velocity is the velocity to escape from the gravitational pull of a planet. So we need to take the work done by the gravity from the distance r from the center towards infinity, and that's the kinetic energy of the object initially have. So now let's calculate this. We have these three are just constant, g m times the integral of r towards infinity times 1 over r squared times dr. is equal to 1/2 mv squared. M actually cancelled out, and we can multiply both by 2. So this term, the integral of r to infinity 1 over r squared times dr, this term is equal to negative 1 r infinity to r, which is equal to 1 over negative 1 over infinity, just 0, minus the negative of 1 over r is just plus 1 over r, so it's 1 over r. So the result will be 2 times g times m divided by r is equal to v squared. So v is equal to square root of this. We still keep the v, just erasing the square. So what is this? 2gm divided by r out in square root. So here we remember what is the constant for g in terms of the gravity. So we know gm is equal to g times mm over r squared, right? So both divided by m to cancel out. So g is equal to gm divided by r squared. So here we have g times r. This is r. But this is r squared. So we need to multiply both sides by r and then square root. So g times r square root, 2 times g times r square root, because here's a 2, will be the answer. C is the answer. The next question. 4 objects are placed at rest at the top of the inclined plane and allowed to roll without slipping to the bottom in the absence of rolling resistance and air resistance. So there's an incline and there's a lot of balls gonna roll down to the incline with some distance. And we need to find out the minimum time, right? So object A is a rolling, is a solid brass ball of diameter d. Object B is a solid brass ball of diameter 2d. Object C is a hollow brass sphere of diameter d. Object D is a solid aluminum ball with diameter d, which aluminum is less dense than the brass. The ball are placed at their central mass and all travel the same distance d. And say, each case the time of motion t is measured. Which of the following statement is correct? We're going to compare the time it took for it to reach the bottom of the incline. So in order to calculate the time, let's find some relationship with velocity, kinetic energy of each of the ball throughout the process. So we know the kinetic energy of each of the ball decide its speed, and its incline is a fixed distance d. So by knowing the kinetic energy, we know the speed. By knowing the speed and we know the incline is constant, we can know which t will be traveling faster or slower. So when the kinetic energy is equal to 1/2 mv squared plus 1/2 times the constant times m times r squared times the omega v over r squared. This is the first part is the normal kinetic energy. The second part is the angular kinetic energy, and k is the constant of coefficient for different angular moment of inertia. This term is moment of inertia. And different solid and hollowed sphere or ball or aluminum ball have different k value. Then we know this kinetic energy is equal to the potential energy, which is equal to mgh. So m all cancelled out, and all we left is gh. So 1/2 v squared plus 1/2 k r squared and r squared cancel out. So we have 1/2 k v squared is equal to gh. So we see that the diameter of the object and the mass of the object are independent of the velocity. If it's independent of the velocity, it's independent of time. So the only thing that matters is this value, little k here. So since we know A, B, and D all solid, or not all solid, yeah, they're all solid balls of different diameter and different mass. But we know mass doesn't matter. So as long as there's a ball, they have the same k value. So TA have to be equal to TB have to be equal to TD. What about TC? TC is a hollow brass sphere. We know the hollow sphere with the same mass should have a higher k value than others do. Higher k value means the higher moment of inertia. So it will take a little bit more time to drop down to the incline. So TC have to be bigger than all of them, which is D. D. This is not an easy one. D. D is the answer. So 11. Question 11. As the shown below, Liddy is using the rope through a fixed pulley to move a box with constant speed v. The kinetic friction coefficient between the box and the ground is mu is less than 1. Assume that the fixed pulley is massless and there is no friction between the rope and the fixed pulley. While the box is moving, which of the following statement is correct? So the magnitude of the force on the rope is constant? I don't think so, because this angle of inclination is always changing. So the tension have to be changing too, but the velocity is constant, remember? The velocity is constant, it just doesn't make sense. So B, the magnitude of friction between the ground and the box is decreasing. That's interesting. Probably is true. The magnitude of friction between the ground and the box is decreasing. Let's see, the magnitude of the normal force of the ground on the box is increasing. Why it should be increasing? Why? Look, this angle is being bigger and bigger. The vertical component of the force is getting stronger and stronger. So the normal force should be less because the block is being pulled upwards. So C shouldn't be correct. So A shouldn't be correct. D, the pressure of the box on the ground is increasing. Now we say the normal force on the box is decreasing, so this should be decreasing, not increasing. The pressure also is wrong. The pressure of the box on the ground is constant, of course, it's wrong, it's decreasing. So the answer is B. 11 is B. Friction, because normal force is decreasing and the friction, constant friction is the same. So mg mu should be decreasing also. Okay, the next question. A rigid hoop can rotate about the center. Two massive strings are attached to the hoop, one at A, the other at B. These strings are tied together at the center of the hoop at O, and the weight G is suspended from that point. The strings have fixed lengths regardless of the tension, and the weight G is only supported by the strings. Originally, OA is horizontal. So now, the outer loop will start to slowly rotate 90 degrees counterclockwise until OA will become vertical, while keeping the angle between the string constant and keeping the objects static. Which of the following statements about the tension T1 and T2 in the two strings is correct? So at the beginning, T1 is horizontal, and after it rotates 90 degrees, this is T1, this is T2 now. What about now? What the tension relationship between these two? So let's just analyze it directly. So first we have a G component, mg, this is G, pointing downwards. So we need to cancel out the vertical component, and the only vertical component, remember, the only vertical component is this tension T. So these two forces cancel out. What about this one? 0. This one should be 0. So which one says there's 0 force? D. So T2 will become 0 at the end of the rotation. This is a fairly simple one. Other thing you can check on yourself. So 13. Show below a graph of the x component of force versus position for a 4 kg cart constrained to move in one dimension on the x-axis. At x equals 0, the cart has a velocity of negative 3.0 meters per second, in the negative direction. Which of the following closest to the maximum speed of the cart? Okay, so let's first find out the work it done by this graph. So first we calculate the area here, and then we calculate the area here minus area here. So the first area will be equal to 1 times 5 plus 1, 2, 3, 4, 5. 5 times 5 over 2 minus 1, 2 times 2 divided by 2. Right, okay. So equal to 5 plus 25 over 2 minus 2 equal to 3 plus 25 over 2, which is equal to 2 to the 31, which is equal to 15.5 joules. 15.5 joules. How many kinetic energy does it gain? So 15.5 joules is equal to 1/2 mv squared. So 31 joules should be equal to mv squared. We know the mass of the cart is 4.0 kg. So 31 divided by 4 square root should be equal to the velocity it gained. So the changing velocity gained. So 31 over 4 square root is equal to 2.78. So negative 3 minus 2.78 should be equal to negative 5.78. I think I did a mistake here. Wait a second. There is no choice at 5.78. Okay, so at this question, this car is initially moving in this direction, 3.0 meters per second. Okay. And the force that is acting on it was constant force with 5 newtons. So 5 newtons divided by 4 kg would be equal to the acceleration, which is equal to 1.25 meters per second square. And that should be a changing velocity for this one. So Vt minus 1/2 at squared be equal to distance traveled. Right. And what is t? Because we want to calculate the distance they travel from here until it stopped. So when will it stop? So 3 times t minus 1/2 times 1.25 times t squared is equal to the range, and t will be equal to v divided by a. So a is 3 divided by 1.25. So let's plug in to calculate what is r. So 3 times 3 divided by 1.25 minus 1 over 2 times 1.25 times the square of 3 divided by 1.25, which is equal to 3.6 meters. So it will travel 3.6 meters until here. So starting from here, we accelerate all the way to here. Actually, we don't consider this part because we want to find the maximum speed of the car. We don't want it to be decelerating. So from here to here, what is the acceleration? 3.6 times 5 is we first want to find the work it done on the cart plus 1.1 times 5 times 5 times 5 over 2 is equal to 35.5 joules. 35.5 joules times 2 divided by 4, which is 17.75, and square root of it is 4.21, which is E. Okay, this one is correct. This is a tough one. Yeah, this is a tough one. So 14, a uniform cylinder of radius A originally had a weight of 80 newtons. An off-axis cylinder hole at 2a divided by 5 was drilled through it. Now it weighs 65 newtons. The axes of the two cylinders are parallel and their centers are at the same height. The force T is applied to the top of the cylinder horizontally in order to keep the cylinder at rest. Magnitude of force is close to 2 watts. So here we have a force acting on the cylinder this direction in order to keep it rotate to this direction, because here is heavier than here. So we can just assume that this is a torque problem. We have the center of circle, center of mass, and here is weightless, and here has some weight, here is some weight, and here is weightless. Other thing is symmetrics. We don't need to consider them. So it's weight of something with this is missing, this is weighted, and we know this hole is equal. The weight of this hole is equal to 65. The 80 minus 65, which is 15 newtons. And we know this length is equal to this length, which is 2a over 5. So we just need to calculate this torque in order to find out the force. So the force acting on here, and the distance should be equal to a. And we want them to be cancelled out. So F times a have to equal to 2a divided by 5 times 15n. So this is equal to 3, 6a n. So F times a cancel out, so F equal to 6n. So F equal to 6n. And that'll be the answer. So question number 15. A cart of mass m has an engine that provides a constant power output P. Assuming no friction, what is the maximum constant speed V max that this car can drive up along the incline and makes an angle theta with the horizontal? Okay, this one should be easy. So we have a cart going uphill. Oh, this is terrible drawing. Uphill. So it need to overcome force, normal force, friction, no friction. We don't consider friction. So overcome a force acting this way, which is mg times sine of theta. This is theta. This is theta 2. Mg times sine of theta. You overcome them. So 1/2 mv squared. No. So the power is equal to force times v, right? Force times v, and the force is equal to mg sine of theta, and v is just v max. Now this is the p. We know the p. We want to find the v, so v is equal to p over mg sine of theta. Where's a? Next one. Now question number 16. Inside the car, there's accelerating horizontally acceleration of a. There's a block of mass m connected to two light springs of force constant F1 and F2, K1 and K2. The block can move without friction horizontally. Find the vibration frequency of the block. So actually, acceleration in here, this scenario doesn't matter at all. What we need to know is these two springs are connected horizontally, so they're in a series. So their spring constant should be add up seriously. So just K equivalent will be equal to K1 plus K2. And we know the frequency equation for the spring is equal to 1 over 2 pi square root of K over n, right? So K equivalent is now equal to K1 plus K2. We plug it in, we find out this equation. So 16 is equal to E. No, E is the answer. Okay, now question number 17. 17 is a data analysis question. It's different than physics, but it's actually very important. It's a math question. So first, let's show below this a log-log plot of the data collected for amplitude and period of oscillation for a certain nonlinear oscillator. Now, according to the data, the relationship between the period t and the amplitude a is given by given to which of the option. So first, let's analyze it like a normal function. Let's write out the function this component is y, this component is x. So we know the slope of this function is equal to what? When it is equal to 1, x equal to 1, y is equal to 5. So the slope of the function is oh no, it's not 5, because 5 minus 3 rise divided by the cross, so 2 over 4, no 2 over 1, 2 over 1, which is 2. The slope is equal to 2. Slope is equal to 2, and the displacement is equal to 3. Since here is 2 and here is 3, so displacement is equal to 3. Then we know y is equal to 2x plus 3. So we now plug in y. Log of t is y is equal to 2 times log of a plus 3. And then we just change the bases. So let's put 10 base 10 below on each side. So we have t is equal to 2 times log a, which is log of a squared. So we have a squared times 10 to the third, right? Because 10 to the power of something plus something is equal to 10 to the power of this times the 10 to the power of this. So equal to a squared times 10 to the third, which is this one. T equal to 1,000 times a squared. Problem number 18. A mass hangs from the ceiling of a box by an ideal spring. With the box held fixed, the mass is given an initial velocity and oscillates with polarly vertical motion. When the mass reaches the lowest point of its motion, the box is released and allowed to fall. To an observer inside the box, which of the following quantities does not change when the box is released? Ignore the air resistance. Okay, here's an interesting question. So we have a box. Inside the box, there is a spring attached to a block, and it's oscillating. And suddenly, the box is released, starting down with gravity g, so it's in free fall. And by the time this reaches maximum, the amplitude reaches maximum. So what is changing? So let's see. The amplitude of the oscillation. I will say it's changing, because at the beginning there is a gravity existed. So by the maximum extension of the spring, it will come back not to the symmetric part, because the gravity is pulling it downwards, so we won't have that much effect. But now the gravity does not exist now, but the extension is still the same. So the amplitude should be increasing. Understand? So if assume there is a gravity force downward, so it will only oscillate the axis force like that. And now the gravity is gone. There's no downward force pushing on it, so it will reach a little more. So it will oscillate like that. So amplitude will be increasing because because blocks in the free fall and the gravity does not have any effect. So A is wrong. The period of oscillation, maybe it's constant. Let's keep it here. C, the maximum speed reached by the max. Okay, because we know the amplitude of oscillation change, the maximum speed reached by the max have to be changed also. So C is also not correct. Height at which the mass reaches maximum speed, because amplitude change is also changing. Maximum height reached by the mass also changing, because amplitude of oscillation is changing and speed has changing. So the period of oscillation does not change. Why? Because we know the period of oscillation. Oops, I should show you the whole options. So the period of oscillation is equal to 2 pi times k over m, right? Oh no, m over k, right? So it does not depend on the gravity. So by changing gravity, it does not affect the period. The only thing affect period is the mass and the spring constant k. So period oscillation does not change. It's B. Okay. Number 19. a 1,500 watt motor is used to pump water a vertical height of 2 meters out of a flooded basement through a cylindrical pipe. The water is ejected through the end of the pipe at a speed of 2.5 meters per second. Ignore the friction and assuming that all the energy of the motor goes into the water. Which of the following is closest to the radius of this pipe? The density of water is rho equal to 1,000 kilogram per meters cube. So now let's draw a picture. A motor is pumping the water out of it at a speed of 2.5 meters per second and have a height of h. So in order to pump it out, we need to consider the total energy. Total energy is equal to the kinetic energy plus potential energy. 1/2 mv squared plus mgh, right? Then because we only want to consider the power, so the power will be equal to the time derivative of it. So what is gonna be? So now we don't need the mass anymore. We will consider the rho, the density. So let's say the density rho, density of the water passing through a surface, the area, cross-section area of the pipe, which is pi r squared, times v. It should be the rate at which the power is pushing the orders out. But this is only considered the kinetic energy part. We also need to consider potential energy. It's also rho times pi times v times r squared times g times h. Why? It's actually simple to think of because we all know is all power have to be overcoming the force that's against the water to be pumped out, a gravitational force, which is mgh. And we know the mass of the water is equal to density of the water times its volume. Its volume is just the volume of the cylinder. It's a cylindrical pipe, which is pi r squared times h. So now we have this equation here. Let's solve for r. So p, simplify it a little bit more. P is equal to rho times pi times r squared v plus gh. So what is r? R is equal to p over rho pi v plus gh square root. Right? This is right? Okay. P over rho times pi times v plus gh, and then of the square root. We know power rotor is 1,500. You divide by 1,000, which is density, divide by pi. Also you divide by 2.5 plus 10 times 2, which is equal to 0.021 meters, which times 100 is equal to 2.1. Wait, I think I made a mistake here. Oh, I forgot to square root it. Okay, square root, and then times 100 is 14.56 centimeters. So it's closest to 10 centimeters. So it's dark. Okay, let's look at the next one. Question number 20. So a container of water is sitting on a scale. Originally the scale reads M1 equal to 45 kg. A block of wood is suspended from a second scale. Originally the scale reads M2 equal to 12 kg. The density of the wood is 0.6 centimeters cubed. The density of the water is the resulting reading. density of water is 1.00 g centimeters cube. The block of wood is lowered into the water until half of the block is beneath the surface, or is resulting in read on scales. Okay. So first, let's decide what is resulting reading on scale for the wood. Because the wood is lowered into the water until half of the block is beneath half of the block. So half of this, so the weight is equal to mg, right? And mg is equal to the density times volume times g. And now the volume is halved. So rho times volume a half times g plus no, volume half of g. No, we shouldn't think about that, because volume of g now because of the buoyant force from the water, there's a half of the volume times the rho of water times g displays out. It's displacing out the wood. So this is pushing upward. This force is pushing upward. So we have rho of wood v times g minus v divided by 2 times the rho of water times g. It's equal to what? Let's use our calculator. The water is 1 g centimeters cube. And we don't know the volume. We don't know the volume yet. So this will be the final weight of the scale. We don't know the volume of the block. So first, we see here is 12.0 kg. 12.0 kg. You divide by the density of the wood in terms of kg. So let's see, 0.6 g per centimeters cube is equal to 600 kg per meters cube. So which is equal to 2 meters cube. So that's the volume of the wood. So now let's plug in again. So water is 1 g per centimeters cube is 1000 kilogram per cube. 1000 times 2 times 10 minus 1000 should be minus 1000 divided by 2, which is 500 times 1000 times 10. Oh, the first one shouldn't be 1000 because it's the mass of the, it should be the density of the wood, so it's 600. 600 times 2 times 10 minus 500 is 1000 times 10. That will be equal to that is strange. Oh, I plug in something wrong again. The volume is equal to 2 divided by 2, which is 1. So the result is 2000. 2000. Very confusing. Oh no, calculate the volume wrong. This is not 100. This is not 2000. It's 12. 12 over 600 is equal to 0.02, right? 0.02. So volume should be 0.02. Remember, stupid. So 600 times 0.02 times 10 minus 500 times 1,000. Oh no, times 1,000 times 0.01 times 10 is equal to 20 Newton, which is 2 kg. So now we have successfully eliminated B, C, D and keep A and E as answer. Mass 2 is equal to 2 kg. The mass 2 is 2 kg, then which means 10 decreasing the block 10 kg, 10 kg force acting downwards. So all the pressure comes into the water, and water pushes the scale. So the M1 will now equal to 55 kg, which is equal to E. Now the next question. A spring system is set up as follows. A platform with a weight of 10 Newton is on top of 2 springs, each with spring constant 75 newtons per meter. On top of the platform is a third spring with spring constant 75 newtons per meter. If a ball with a weight of 5 newtons is then fastened to the top of the third spring and then slowly lowered, by how much does the height of the spring system change? Okay. Because here, 2 springs are connected parallelly, so their spring constant add up. So 75 times 2 is 150 newtons per meter. And here just 75. Oh no. The spring constant 75. Okay, both 75 newtons per meter. So ball is placed here. It's 10 newtons. Downwards, 10 newtons, which are compressed these two by 10 newtons. So 10 newtons over 150 newtons per meter. Cancel out. 1 over 15 meters. 1 over 15 meters. And also this 10 newtons is compressing this spring scale here. Here. So 10 newtons divided by 75 newtons per meters, which is equal to 10 over 75 meters. So these two plus together, we got the answer is 10 over 75 plus 1 over 15, which is 0.2. No, that's not the answer. Not 0.2. Let's overthink something. Oh, the ball has a weight of 5 newtons, and the platform has a weight of 10 newtons. This is 10 newtons. This is 5 newtons. So the totally force acting on them is 15 newtons. So this is 1 over 10, not 1 over 15, 1 over 10 meters. And here it should be 5 over 75, so it's 1 over 15 meters. So 1 over 10 plus 1 over 15 is equal to 1.0. Okay, so number 21, now we get it. Because we want to find out the change in the height of the platform on the system. So at the beginning, the platform has 10 newtons acting on downwards, and there's no force acting on here. So it's assuming the spring is massless. So 10 newtons divided by 150 newtons per meter is equal to 1 over 15 meters. And now because we add a little ball here, okay, the total system is compressed a little bit more. by a amount of 15 newtons divided by 100 meters now. So now it's 1 over 10 meters. But also because of this because of this ball, the top spring is compressed. So 5 over 75 newtons per meters is equal to 1 over 15 meters. So 1 over 15 meters plus 1 over 10 meters will be the situation now, and the original one is 1 over 15 meters. So 1 over 15 meters plus 1 over 10 meters minus 1 over 15 meters cancel out. It's just 1 over 10 meters. So the answer is C. Okay. Problem number 22. Softest audible sound has an intensity of 10 to the negative 12 watts per meter squared. In terms of the fundamental units of kilogram per meters and seconds, what is it is equivalent to? Okay, so this is a unit change problem, as a unit problem. When the work is equal to 1 half mv squared over 2, right? So m is equal to mass, v is equal to mass is equal to ag times velocity squared times s squared divided by s again over 3 divided by meter square. We cancel out, so we have kg over s3. So the solution for 22 would be kg over s3, so it's A. Okay, next problem. Final sheets of problem. So problem number 23. Which of the following sets of equipment cannot be used to measure the local value of acceleration due to gravity? For a spring scale with a known mass, of course, yes. A rod of known length and known mass and a stopwatch. So we can create a pendulum, and from the period of pendulum, we can calculate the gravity. B, yes. An inclined plane of known inclination, several cars with different known mass, and a stopwatch. Well, probably not, because we don't know the coefficient of friction and the inclination angle. So probably not. A launcher with launch projectile at a known speed, a projectile of known mass, and a meter stick. Okay, so we use projectile motion to consider gravity. So yes. Motor with known output power, known mass, a piece of string of known length, and a stopwatch. Well, this is really interesting. We can use the motor to counter the gravity to create a power upwards, a force upwards to counter the gravity, anti-gravity device. We find the balance between the motor power with the gravity. We can find out the magnitude of gravity. This one's yes. So C cannot be done because we don't know the inclination angle and we don't know the friction between the incline and the mass. So problem number 24. Problem number 24 is a very interesting one. So we first 3 points mass M attached together by identical springs. When placed the rest on the horizontal surface, the mass from triangle with length L, and this is 60 degrees because equilateral triangle. When the assembly is rotated about its center with angular velocity omega, the mass from a triangle with side length 2L, so it doubled the length 2L. What is the spring constant K of the spring? Oh, that's good. So first we need to have three different concepts here. First is centripetal force. Second is the force by the tension of the spring, and also we need to use some geometry property. First, on the center mass, here's a distance. Here, there's a force component acting on each of the point, trying to push it away, because the centrifugal force is pushing it away. And the spring constant, the spring tension force is producing that centripetal force. So what is the centripetal force? Centripetal force is m times omega squared times r. The centripetal force. What is r? R is a hard thing to calculate with geometry identity. Let's leave it here. Is equal to the tension in the spring, 2 times the tension of the spring times cosine 30 degree. Why? Because we can split, because this line through the center on one of the tip point, we have 2 angles that have 30 degree and 2 tension force acting this way. So t times cosine of 30 degree times 2 will be cancelled out with the centrifugal force, which is the centripetal force. And what is the tension? And what is the r? Omega squared times r is equal to 2 times k times L. Why? Because the spring potential energy, as the spring force, is acted by k times L, the changing length, times the spring constant, times cosine 30 is 3 square root of 3 over 2. So these two cancel out. And what is R? The R is m from the point mass m to the center of the equilateral triangle. And side is 2L. What is it? But these 3 lengths should be the same. When you remember. So 30. So let's use geometry here. First, let's calculate what is this length. This length is L. This length is 2L. So what is this length? This length will be L times 2 L squared, 2L squared minus L squared, or the square root. So it's 4 times L squared minus L squared over square root, which is 3 square root of 3L. Just square root of 3, square root of 3L. And what is this length? This length to here, this length. This length is equal to L times the square root of 3L over 2 divided by 3. Divided by 3 is the area of this triangle, which is equal to L squared times the square root of 3 divided by 6. By 6. Then we time this by 2 and then divide it by L. We get this length. So length is L times square root of 3 over 3. Okay, now the square root of 3 is L minus L times square root of 3 over 3 is equal to the square root of 3 over now 3 times 2 times square root of 3 over 3 times L. Now that will be L. That will be the R length. Okay, let's write it here. Now it's fine. So m times omega squared times L times 2 times square root of 3 over 3 is equal to KL times the square root of 3. Square root of 3 cancelled out, L cancelled out. So K is equal to m omega squared times 2 over 3. So the solution is C. Okay, solution is C. Now the last question, finally. So consider 2 orbits around the Sun, shown below. Orbit P is circular with radius r. Orbit Q is elliptical such that the furthest point B is between 2r and 3r. The nearest point is between r over 3 and r over 2. Consider the magnitudes of the velocity of the circular orbit Vc, the velocity of the comet in elliptical orbit at the furthest point Vp, and the velocity of comet elliptical orbit at the nearest point, VA. Which of the following ranking is correct? So clearly we know VB is smaller than VC is smaller than VA. But it's probably very tricky. See here, they multiply something by a constant. Very tricky, very tricky. So by the information produced here, we know this is R. Distance from here to here is equal to 2 to 3R. A is equal to R over 3 to R over 2. Okay. So by balancing the gravity and centrifugal acceleration, we have Gm over R squared is equal to mv squared over R. So we multiply both by R with m. M cancel out the b times R equal to Gm over x to Gm. So V is equal to Gm over R, square root of Gm over R. Okay, so VB is equal to Gm over 2 to 3R, square root. VA is equal to Gm divided by R times 2 to 3. VC is just Gm over R. So now let's compare them. Is VB bigger than VC bigger than 2VA? Of course not. VA is the biggest. You do multiply by 2, so this is completely wrong. 2VC is bigger than VB is bigger than VA. VB is smaller than VA. This is wrong. 10 times VB is bigger than VA, bigger than VC. VA is bigger than VC, of course. 10 times VB is equal to about, so 10 times VB, so the square root of 10. 10 times VB will be 100 times this divided by 2. So 100 divided by 2 or 3 have to be bigger than 2 or 3, right? So VB 10 times VB have to be bigger than VA, and VA is bigger than VC. So this is correct. And let's look at the D option. D option says VC is bigger than VA, VC is bigger than VA. Of course not. 2VA is bigger than square root of 2 times B. Yes, of course, but B, square root of B, square root of 2 times B is not bigger than VC. Square root of 2 times B is not bigger than VC because these two probably cancel out. But this is still a lot bigger than this, no matter how you divide it. So this is wrong. So the answer is C. And that's all we got for 2012 F equals MA exam. And we need to thank you for American Physics Teacher Association to produce the solution sheet which we referenced.